we'll be discussing the triangle inequality theorem and its proof. Before we discuss that proof, we must go over another proof called the shortest distance theorem. That theorem just states that the shortest distance from a point P to a line S then is the line perpendicular to S passing through the point P. In this diagram here then, the shortest distance between the point P and this line S is this line segment in blue from P to R. For the proof of the triangle inequality theorem, we started with the triangle ABC and the line perpendicular to BC passing through A then is labeled this blue line segment A to E. Now we must prove that the side BA plus the side AC then will be greater than the side BC. Since BE is the shortest distance from the vertex B to the line segment AE, then we know that the side BA then is longer than the side BE. Likewise, since CE is the shortest distance from C to AE, then the side AC will be greater than the side CE. By combining both inequalities by addition, BA is greater than BE and AC is greater than CE, we get BA plus AC is greater than BE plus CE. But we know that BE plus CE then just gives us BC. So by substitution here, we end up with BA plus AC is greater than BC. In general terms, all that states is that the sum of any two sides of a triangle will be greater than the third side of the triangle. We can easily see that using GeoGebra. Triangle ABC then is shown here. In this case, side A measures 5.9, side B measures 5.9, and then side C measures 5.3. But if I click on a vertex, I can easily drag the vertex around. All that does is changes the lengths of two sides. If I drag vertex A around, side B and C change length, but side A stays the same. Now my triangle inequalities are shown here. A plus B is greater than C, B plus C is greater than A, and A plus C is greater than B. If I were to move A around, you notice that the measurement of A stays the same and B and C change. So then I know, according to the theorem, that the measurement of B plus the measurement of C will be greater than the measurement of A. Now B plus C gives me 6.7 plus 7.4. That sum is 14.1. Certainly is greater than 5.9. Dragging A around, I can get different values for BC. However, those sums will still be greater than 5.9. I can do the same thing by moving B. If I move vertex B around, I notice that the B side stays the same, but A and C change. According to the theorem, A plus C will be greater than B. In this case, 5.2 plus 4.9, sum of 10, certainly is greater than 4.3. And again, I can move around the vertex B. Those sums of A plus C will always be greater than the length of B. Moving C around, same thing happens. I notice if I move vertex C around, the length of segment C stays at 3.3. However, the A and B will be changing. If I stop here, I notice that A plus B should be greater than C. A is 4.1, B is 5.7. Sum of 9.7 certainly is greater than C, which is 3.3. All the theorem states is that the sum of any two sides will be greater than a third side.